what you have to keep in mind here. Now there's a simple pendulum. We have a length of uh, the length of the string. So L. So this usually the bob. No, the bob also will have the radius practically. So in our theoretical questions, all we made as a point object. That's why he is writing L plus small r. Length of the pendulum is not length of the string. It will be L plus r. Usually in the, if you go for the lab, no. So this will be the string. Then we'll get a this will be usually bob. So that will be very small. So let's not. So usually I'll tie this one. So this is the radius r. This is the what the length. So to trouble you in exam, they'll give radius of the bob. In that case, the length of the pendulum will be L plus r. It's missing here. These things is what you have to trouble. So definitely when you're finding the radius of the bob also, you'll do some error. Measuring the length of the also, you'll do error. Then you go for error analysis. So what is it? Usually we are interested to measure the time period, no? So the acceleration due to gravity. What is the major purpose of this? Acceleration due to gravity. So the expression will become 4 pi square L plus R into T. Okay, this one. So what is the L plus R? You call that as a some quantity. Let it be say A or beta. Some P. I'll write it. Now delta G plus or minus G. G should be equal to delta P plus or minus. What is P? P is L plus R. This will become plus or minus. I do some questions are available like this also. They will trouble you. You have to be careful. This we are going to substitute here. So plus or minus delta G by G equal to plus or minus. This will be delta L. Sorry, it is. Okay, be careful. We don't have till now any question, but can be stressed like this. If they give radius of the bob, length of the string, the formula will get modified here. Most of the cases, we assume that radius of the bob very much negligible compared to the length. In that case, what happens? The expression will become T square, no? I think I did. No, wait. So some. Okay, introducing the 2 into or I forgot that. Yeah. If delta R is negligible, I think that this, you're very familiar. But even this can be asked in exam. You have to be careful. Okay, maximum you concentrate on every experiment. The error analysis you concentrate. That's what the need of the exam. What are the things what we should we are neglecting? So is it a what we do? Is it exact or will be error? There'll be error because there'll be spinning of bomb will be there. So usually it will have a spin. Okay, and the point where we suspended, no, and because of this, the twisting will be there. So what are the things which we are neglecting, which we don't consider? Wobbling of bob. So for the moment of inertia, you have to make slight correction. So wobbling of the bob, then afterwards, the twisting of wire, buoyancy of air. Okay, all this what happen will lead to some error. Okay, that's why what happen when we do experiment, we should not get exact value, we should get some error. So definitely they may test what are the possible uh, errors what happen which we don't usually consider. That one, wobbling of bob, the bob what happen will also the spinning effect, the moment of inertia will change. It should not be just only mgl ml square. So spinning effect has to be taken. Twisting of wire, then buoyancy of air. So all these things is what happen have to be considered. Okay, these are some theoretical things. And this is some extra things. I think this is the first time what you have seen, but it's a lab manual. If you take it, no, we do have a description like this. How they will trouble you questions like what happens if I pick up a bob of radius which is comparable to length, then you have to do like this one. If the radius of the bob is very much less compared to length of the string, then use this one. Okay, I'll proceed down. Any doubts if you have, you can ask it. Then what we do, I'll calculate the time period for some oscillations. Okay, this one for 10 oscillations, what is the time taken? Next for another 10 oscillations, for another 10 oscillations. Like that, what happened? For I'll calculate the time taken for 10 oscillations. Then I'll take the average time for 50 oscillations by 50. Will give the time period. Then I'll take the average of that one. That I'm plotting here. T square versus L. As I increase number of oscillations, tell me what will happen. The fractional error will decrease, no? Or what you can call random error will decrease. So therefore, what is advisable? Number of oscillations should be more. That's why you see like he has made 50. So how this error inversely proportional to random error is inversely proportional to number of observations. So if I go for more number of observations, the random error will decrease. I think that n is adjusted here. Am I right? That n is adjusted. What is n? N is number of oscillations. Okay, I get this. This one. Chat box. Let me check the chat box. Who is Ramesh here? Anybody? Who is Ramesh here? Which section you are, Ramesh? Section. I'm asking section. Alpha, junior alpha. I don't know. Okay, no. Any doubts you can clarify, please. Anything related to experiment?